Okay, so recall that because a rhombus has all equal sides and opposite sides are parallel, this is also a parallelogram, which means if we want to find the area of it, we can use the same formula, base times height. Unless we're not given the height. If you're not given the height, that imaginary dotted line, then it's really hard to find. Unless you're given an angle, then you can use trig. And so we have another formula for finding the area of a rhombus that involves the diagonals. Because the diagonals of a rhombus bisect each other and are perpendicular to each other. So to demonstrate this formula, go ahead and draw the first diagonal of your rhombus, or one of the diagonals. Let me try that again. That was ugly. Why is it doing that? So one of the diagonals. And let's call that diagonal D1. Okay, so the length of that diagonal we'll call D1. And then draw the other diagonal. And let's think of that as
Looks like a kite.
D2. Looks like a kite. Now, for the sake of the formula, I'm not going to worry about this entire second diagonal. I'm actually going to cut it in half. So I'm going to erase this part. And so the length of this green thing would actually be not the whole diagonal, but D2 divided by 2. So what do you think so far? So we've got one of the diagonals, and then we've got half of the other diagonal. Now notice what shape we have here in the upper left corner. We've got a triangle. And that triangle is exactly the same as the other triangle. If I turn this around, they should be, assuming I trace it right, they should be pretty darn close to the same. In fact, they should be exactly the same. All right? And so, if we can find the area of this triangle, find the area of the whole rhombus, we would just double that area. Everybody okay with that?
Yes.
So let's find the area of this triangle. For reference, it's called ABC. So, area of triangle ABC. Well, we actually went over the area formula for a triangle. What was that formula again?
It was half of base times height.
Very good. So 1/2 of base times height. All right. So
Can you take out that half?
we've got 1/2. Now base 1, or I'm sorry, the base would be the diagonal, right? So we'll call that diagonal 1 times the height, which the height is half of diagonal 2. So diagonal 2 over 2. Okay. Now, because multiplication, multiplication is commutative, we can multiply this half by this half and get 1/4. And we have D1 times D2.
How come you did D2 to 2?
Because to make this triangle, I want half of diagonal 2, not the whole thing. Okay. Now we have how many of these triangles in this rhombus? We have these triangles. 2. So we found the area of this. All right, that's the area we found. So if we just double that, we'd have the whole thing. So the area of our rhombus, would be 2 times 1/4. D1, D2. If we multiply 2 times 1/4, well, if you have 2 quarters, that's half a dollar. So 2 times 1/4 is a half. D1, D2. And so there's another area formula for a rhombus. Now, again, because a rhombus is a parallelogram, if we know the base and the height, we don't need to worry about those. There's 2 base times height. But if we don't, and we can find the diagonals, then we can multiply the diagonals and cut it in half. Because a rhombus has all equal sides, it follows that the perimeter of a rhombus would be 4 times the side length. Why 4? Why 4? Why not 5 or 6 or 7? So there's 4 sides and they're all the same, so 4 times the side length. Okay, so we're going to do 3 examples. Example 1, you're not given a picture, so you should identify, okay, it's talking about a rhombus. So draw a rhombus. So what is the area, side length, and perimeter of the rhombus having diagonal lengths of 12 and 16? So we've got a rhombus. We've got diagonals. So let's go ahead and draw the diagonals on here. And when you draw your diagonals, one of them should appear shorter than the other. Right? I mean, they're not the same length unless it happens to be a square. So one of them should be shorter. So in this case, the way I have it drawn, this one's shorter. So this diagonal is 12. But the diagonals bisect each other. So how long is this part right here? Okay, so this is 6, and this is 6. And what about the other two? 8. Okay. Now the other part about rhombi and their diagonals is they intersect. The diagonals are perpendicular, which means what? Into right angle. And so this corner up here is actually, if I move it over, is actually a right triangle. And so I've got 6 and 8. And the side length would be that side x. Right? So what can we use to find that missing side in the triangle? So x equals the square root of 6 squared plus 8 squared. Write it down. You're waiting for me to write it down, aren't you? And then you're going to copy it down?
So you're like diagonal?
Nope. That's not, I'm not.
Or is it like what?
Oh. So we get 10. And that's the side length. Okay. Now, do we need to know the side length to find the area?
Yes.
So what formula do we use for the area?
6.
1/2 and 1/2. Or 1/4. 1/4
Huh?
I feel like I should rewind about 10 minutes.
times d2.
6 times 6.
What formula are we
Base
going to use
times-
to find the area of this rhombus?
Base times side. Oh,
1/4. A rhombus.
1/2 cube 1.
wait, what?
Wait, 1/2 6.
So we just went over this nice new formula for finding the area of a rhombus.
1/4.
Right?
That's right.
1/2 diagonal 1 times diagonal 2. So do we need the side length to find the area of a rhombus?
No.
Absolutely not. Yes, Weston.
But it's a quadrilateral, and it's basically a parallelogram. It's when you find any parallelogram, you use base.
That's true. So what's the height of this parallelogram? No, we don't know, and we actually, to find it would be a whole lot of work. I'm not even sure that it's possible. I'd have to think about it a little bit more. But all right, so we don't know the height, but we know the diagonals. So why do a whole bunch of extra work if we're given useful information? The area will be 1/2 diagonal 1 times diagonal 2. Which in this case, 1/2. Now, it doesn't matter which one we call diagonal 1 or diagonal 2. It's just one of the diagonals and the other one. So are we going to use 6 and 8? Okay, we'll use 12 and 16, the actual length. So 12 times 16. So 1/2 of 12 is 6, and 6 times 16 is 96. Okay, so we don't need the side length for the area of a rhombus, as if we have the diagonals. Do we need the side length for the perimeter of the rhombus? Okay. How many sides are on the rhombus? And how long is each one? There was 10, so we've got 4 times 10. Example 2. For the rhombus shown here, find the lengths of both diagonals, the area, side length, and the perimeter. Okay, so lengths of the diagonals. So how long is the shortest diagonal?
8.
How long is the longer diagonal? So we've got diagonals. Once we know the diagonals, what can we find?
Side length.
We can find the side length and we can find the area, right? So we need to, if we find the diagonals, we can find everything basically. So let's find area. Area will be 1/2 times 8 times 10. Half of 8 is 4, and 4 times 10 is 40. To find the side length, we have to again recognize that we have a right triangle. So if I call that x, which you can call whatever you want, but x. X will be the square root of plus 4 squared, right? So we're looking for the hypotenuse, so square root of 5 squared plus 4 squared. 6.4, give me 2 more decimals.
Oh,
0.03.
Okay. There's our side length. Good. So we get our perimeter, we take that and multiply it by 4 because there's 4 sides. So 6.403 times 4 gives us 25.612. And then finally, example 3. A certain rhombus has an area of 100 square meters. If the longer of the two diagonals is 17 meters, how long is the shorter diagonal? So this is a unit, remember? If this were a meter, a square meter would be something like that. So this is saying 100 of these squares will fit into the rhombus. That's what it means. So we're not squaring 100. So we're given an area of a rhombus, and we're given a diagonal of the rhombus. So let's start by writing down our formula. Area equals 1/2 d1 times d2. In fact, in general, if you're given information, we could have done this on the first example too. If you're given information and you have a formula that relates directly to that information, you might as well start by writing down the formula and plugging in everything you know. If you can find if you know everything but one variable, then you can solve the equation. So do we know what A is?
yes, 100.
A is 100. Okay. A half is a number, so that stays put. Do we know what D1 is?
Yes.
Okay. D1 could be 17. Do we know D2? Okay, so that's what we're looking for. So we know everything except for D2. So that means we can solve this equation. So we can actually multiply the 1/2 and the 17. Right? So we get 100 equals 8.5 D2. And then divide by both sides by 8.5. 11.765. All right, any questions on those 3 examples? So the rest of the problems are similar to those. Are there any questions? Anything? Couldn't read my writing or anything?
Wait, can you go down?
That's as far as it goes down.
Well, isn't that only half of the shorter diagonal? So wouldn't you have to times it by 2?
Remember the reason that we wrote D2 over 2 right here was because we were talking about half of D2. Okay, so D2 divided by 2 is half. D2 is the whole thing.
I know.
So when we solve for D2 right here, we actually found this is the length of the second diagonal. Because the half is built into that formula.
Oh, okay. Okay.
So if you look at the first 3 problems, those are like the first, or I guess example 2, basically. Number 4 is like example 1. Don't ask me why it's out of order. Number 5 is like example 3. And then 6 and 7 are both like example 2, except instead of being given side lengths, you're given angles. So you have to use trig ratios or special right triangles. Okay, but it's all the same idea.